Welcome to Honors Geometry, lesson 1.1 and 1.2, where we talk about the fundamentals and building blocks of geometry. Now, geometry was based on the geometry that we're going to study, based on a Greek guy named Euclid, who put a bunch of mathematics together, called it geometry. And what he started his system with were three things: points, lines, and planes. And in order to build a logical system, it is actually, you have to start with unknown items or undefined items. And the undefined items that Euclid started out with were points, lines, and planes. So let's go ahead and talk about points. I know I said they're undefined, but we will still talk about them, but try to stay away from a formal definition. Alright, let's see if I can get this thing working. Okay, a point has 0 dimensions. It has no width, it has no depth, it has no height. We will use a dot on a piece of paper to signify a point, just so we know where it's located, and that's the whole point. Haha, that's the whole point. Get it? That's the whole point, to find out where it is. A point is labeled with an uppercase letter always. Never will a point be labeled with a lowercase letter. Uppercase letter only. And yeah, we're going to build everything else up from points. The first thing that we're going to build up is a line. A line is a straight arrangement of points. It has an infinite number of those points. Okay, and yeah, okay, that's kind of weird. You add enough points together which all have no dimensions, and you actually get one dimension. You get length. The word length itself has the root word in there that's related to the word line. There's a vowel change with the E, but other than that, it's still related to the word line. It's what length, it's where we get the name from. Alright, how do we name a line? We will name a line using any two letters that are on the line. So we could name that line right up there, hear this thing, AB or BA, or AC, or line CA, and we will put a bar with arrows on both sides to denote a line. Or we could say line AD or line DA. Or we could say line BC, or we could say line CB, bar with two arrows. Or we could say line BD, no, not BB. I said line BD. Or we could say line DB. And of course we could also say line CD, or we could say line DC. There you go. 10 different ways to name that line right there. But wait, there's more. Sometimes, like in chapter 3, when we talk about parallel lines, we will use lowercase letters, and we'll say line, whoops, P. And that is a lowercase letter, and it's always associated not with a dot, but at the end of the line where the arrow is. That says line, it really does. And this is line M right here. Now there are parts of lines. One part of a line that has a beginning point but no end point, it's called a ray. Another part of a line is a segment. It has beginning point and an end point, or it has two end points, and this is sometimes called an end point also. So this is a ray, this is a line. And we need letters to name it. We'll go X, Y here and F, G. This is this is ray X, Y, bar with an arrow pointing to the right. Always. The arrow always points to the right. It has nothing to do with this diagram here. It has everything to do with that endpoint first. X is where it starts, and then it goes through Y and keeps on going. And then segment GF will just have, FG, will just have a bar over the top with no arrows, meaning that it ends at both points. Alright, so that's how you name array. Endpoint, always going to the arrow, always pointing to the right. And that is how those are parts of a line. Okay? And the last undefined term, planes. Oh, wow. I can't believe it. I forgot to tell you that lines, well, I did tell you about length. They have one dimension. Yes. Alright, planes. Planes have two dimensions. And those dimensions are length and width. And how we are usually going to denote a plane is a parallelogram. How are we going to name that plane? Nice parallelogram, Mr. Manning. Well, thank you very much. By naming 3 points on the plane that are not all on the same line. And we will say plane F, G, H. And that's how you name a plane, using 3 points on it. Or there may be a possibility that over in the corner, with no point associated with it, it's just written in the corner, we might be able to name that plane just by using that letter in the corner, capital M. Kind of like what we did with the lines, where we used a lowercase letter to name a line. Kind of like that, but we're using an uppercase letter to name a plane. And those are the 3 building blocks of points, lines, and planes. The next section that we're going to talk about from section 1.1 is called intersection. And first I want to give you a non-geometry example to talk about intersection. And we'll use the intelligence, Venn diagram, social ineptitude, and obsession. And yes, at times I've been all of these. A geek, a nerd, a dweeb, and a dork. The intersection of intelligence circle and the social ineptitude is dweeb and nerd. The intersection of the social ineptitude and obsession is dork and nerd. The intersection of intelligence circle and obsession circle is geek and nerd. The intersection of all 3 is nerd, because it's in all of them. Okay, dweeb and nerd are shared by intelligence and social ineptitude. That's what intersection mean. In the geometric circles, circles, that's funny. Intersection is the set of points that 2 or more figures share. So in the first picture here, I have 2 lines that are intersecting. Line LM and line AM. Those 2 lines are intersecting. Those lines, well actually it's ray AM and line LM. Okay? Those 2 intersect at point M because they share M. They have M in common. And then the next figure I have for you is 2 intersecting planes. A vertical orange plane and a horizontal blue plane. They intersect and share a line. Somewhere it's here. Oh, I lost it. Anyway, the line is right here where the 2 planes intersect. And that's what intersection is about. Opposite rays. Opposite rays are rays that intersect at their endpoints and form a line. So in this picture, ray SW and ray ST are opposite rays. And notice again, I didn't say ray ST, or I didn't draw the ray going in the other direction. The arrow was always pointing to the right. Ray ST starts at S, goes through T, and keeps on going. Ray SW starts at S, goes through W, and keeps on going. Ray ST, ray SW. Okay. Collinear points are points that are on the same line. A, B, C, D, and E are collinear points. They're all on the same line. A, B, and G, those are non-collinear points because they're not all on one line. Collinear, they're on the same line. Coplanar points. Coplanar points are points that are all on the same plane, like A, B, and C are all on plane E. A, B, and D, since D is underneath this plane, those 3 points are non-coplanar. Oh my goodness, you can't even read what I'm writing because I'm writing behind my face. There, now maybe you can see what I was writing. Yeah, I forgot that sometimes I'm hiding stuff with my face. Alright, and that is the last part of section 1.1. So now we will move to section 1.2. Oftentimes we're going to notice that we start out with a definition and we end up with a postulate or theorem, and then we do some practice, and that's the case with this one. Here's the definition. A postulate is a statement accepted as true without proof. And here is your first postulate that you're going to accept as true. If point B is between A and C on a line, then AB plus BC equals AC. The first part, AB, plus the second part, BC, equals AC, the whole thing. Hey, what's this little asterisk here for? Hey, let's find out. Let's go ahead and move on. AB is a new symbol that means the length or distance from A to B. So now we have a bunch of different possibilities going on here. Okay, AB could be a line if it's associated with that. AB could be a ray with associated symbols. AB could be a segment with that symbol. And this AB is a completely different thing, meaning a length. Alright, so, ready? Make an equation with this setup. Y is between X and Z. You should be able to say XY plus YZ equals XZ. Okay, really simple. The first part plus second part equals the whole thing. Alright, let's go ahead and make one more. Alright, you make the equation, write it down on your notes before I do it. Alright, so go ahead and pause this while you write. Hey, I told you to pause that. Now pause it. Thank you. Your equation should have been LM equals M. No, you guys. LM plus MN equals LN. That's correct. And the last screen of the day is congruent segments are segments that have the same length. This right here says that segment AB and XY have the same length. This is a length. This is a length. This says segment AB is congruent to segment XY. Numbers, and these lengths represent numbers, are equal to each other. Figures are congruent. Numbers are equal. That's something that you will forget. And I'll just say, remember on the first video, right at the end, numbers are equal to each other. Figures, segments, are congruent to each other. A, B, and XY, they represent lengths. This does conclude section 1.1 and 1.2, Honors Geometry.